So we're looking at some basic Python programming of things that you should already know. And we're just kind of using those to build some different types of script. Now this particular one is known as the random walk. Of course, this is going to be the random walk in one-dimensional space. Okay. So I'll attempt to draw a straight line here. And let's see, we'll just label this as 1 here, and we'll label this as not 200. I don't know why I did that. Okay, we'll say 100 here. But what we're going to do is we're going to start off with 50. This is where we're going to start on our random walk. Okay, and you know what? Tell you what. I'm here at awwapp.com. They've got a nice little built-in marker board. Okay, so we'll say this is 49 and this is 48. 40. Whoa, what am I? I don't know. Don't ask. Please don't ask. Okay, 51. So we're on the number line here. 52, 53, and we'll just say this is 54 and 49, 48, 47, 46. Okay, so this is where we're going to start on our random walk. And what we're going to do is, I'm just going to say choose a number between 1 and 0, and this is going to be like going left and going right. Okay, so in other words, if 0 comes up, then we're going to take 1 step to the left, right? And then what we're going to do is go back and generate another number, random number between 0 and 1. And let's say that 0 comes up again, and so then we take another one, we take 1 step to the left, and now we're at 48, right? And then we generate another random number between 0 and 1. Let's say 1 comes up this time, and then we go back to 49, and then we do it again, and let's say that it's a 1, and so we go again, and then let's say we do it again and we get another 1, and then another 1. Let's say we get a bunch of rights in the row here. Alright, and then so let's say, for example, we want to stop the program when we get to 55. So let's say that this just happens to happen over and over again, that we keep getting 1s, and then finally we're at 55, and then we'll say that the program stops when we're at 55. And what we're going to do here is we're going to go ahead and count how many steps it takes, okay, before we come to a certain point. And that particular certain point here, let's say, is 55. So I thought this is a really interesting problem here. Write some script on, because there's a lot of things that we're going to actually do with this. And actually, I think I turned it into a probability problem somehow at some point in time. But okay, so let's write an algorithm that will do this and count the number of steps to a certain number. And we're going to go ahead and start our random walk at 50. All right. So let's go ahead and bring up the editor here. Okay. All right. Well, since we're talking about random numbers, what we'll need to do is we'll first have to import the random module. So we just say import random module, and we're going to create a list here, And then of course we'll have to count, keep up with some things. This P is going to stand for position, and we're going to start with position 50. Starting at position 50. Right. Okay, so here's our loop. While true, we'll just go ahead and set that to true. Alright, and this right here, this dir will be direction. Alright, the direction, random integer between 0 and 1. Alright, so remember, if it's 0, we're going to go left. If it's 1, we're going to go right. Just one position. Alright. Okay, so let's do an if statement here. We got if the direction is equal to 0, so remember that we're going to take off going left. So P is equal to P minus 1, right? So P starts off with 50, and then we subtract 1, and so now the new P becomes 49. So that's pretty easy. Right. Else, right, if it's not 0, then it must be 1. So that means that P is equal to P plus 1. That means we're going going to the right. Now we'll need another if statement here. Is that lined up? This really needs to be lined up with, or we're going to get an error. And then now what I'll have to do is go down here and line that up. Yeah. Okay. Alright, if P is equal to 55, so if our position finally lands at position 55 on the number line, number 55 on the number line, however you want to look at that, then the programs will break. This will break out of the while statement here. Alright. Okay. I'm trying to think here why it is. Trying to remember why. Oh, why I was storing the position. Yes, I remember now. Okay, there's a reason why I'm storing. This is not necessary. Actually, let's do this before here, let's go ahead and print. We're going to print off, so every time we get our position, we're going to print off that position. Okay. And let's see. C, we'll need to do this. Why do we need to do that? We don't. This is just counting the number of times this thing goes through. Yeah. So how many steps does it actually take? And we'll print that off. Actually, we'll do a little divider here so we'll know the difference. Let's go to next line, and we'll print off C. Okay, this is just going to divide our data that we collect, right, with the number of steps that it actually takes. So every time this thing loops through, we're going to count, right? That's going to be the number of steps that it takes. Okay, so I think that's pretty much it. And we're going to get fancy with it here in just a minute. Let's go ahead and run this. Whoa, look at it go. Whoa, wait a minute. We got some why does it keep going? Okay, something's fishy here. Man, surely not. Let me break this program. I mean, I guess it's possible, but I'm going to kill the program here. Okay. Oh. dir is equal to 0, subtract 1, that's true, else add 1. Print P is the position. Okay. I don't know, it all looks good to me. Let's go back. That was pretty bizarre. That last one, I mean, it's possible, I suppose. Okay. That it could have just kept taking off to the left. That's probably what happened. Okay, so as you can see here, so we started at 50 on the number line. Okay. And then it went, actually, you know what, let me bring this down so we can actually see the scribble that I scribbled up here on the paper. So we started at 50, and then it went to 51, so that was actually the next step. And then it goes to 52, 53, and then it went back to 52, as you can see here, and then 51, back to 52, then to 53, 54, and then of course the last one, which is not actually being printed out onto the page here, then it went to 55. And of course it says here how many steps, so 50 to 51 would have been 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then of course to 55, right? So 54 and then to 55 would have been 10. This is actually, right, the 10 that it's counting. So it took 10 steps to get to 55. I think it's quite interesting, right? It's called the random walk in one-dimensional space. So if you're a flatlander, I guess this is how things work. All right, let's actually run the program again and see what we get on that. Okay, this time 24 steps. Let's do it again. 24, wow, 24 again. Ooh, 74 that time. Okay, so here's an interesting question. How far to the left, when we started here, how far to the left did we end up traveling before we came back finally to 55? And so what we'll do is to figure that out, is we will, actually there's a couple ways of doing it. That I think about it. There's actually, there's a lot of ways to do certain things when you're programming. Okay, but what we're going to do is we're going to go ahead and just store every single one of these positions in a list, and then what we'll do is we'll sort the list from smallest to largest, and then we'll just look at that very first value, because the very first value will be the smallest value, and that'll tell us how far on the line here we went over to the left. And okay, so let's go ahead and go back to our script here. All right, okay, so what we'll want to do here is that's what this A here was all about. Let's get this whole thing on the screen here. Okay, that's what the whole A was. So what we'll do is we'll take A and append P. That means that we'll take all our positions and put them in we will put them in container A there, as you could say. And then what we'll do, when we're completely done, we will sort, and that'll sort it from smallest to largest. Alright, we'll sort A, and now, okay, so let's see, that's the number of steps, and then we'll go ahead and go to the next line, and then this one here will say the minimum. We'll just call it the min is, and So it would be that first element in list A, and that would be a sub 0, right? Or a of 0, here if you want to say that. Alright, so let's run that and see how that works. Okay, the min is 50. So as you can see here, what happened, so we started off with 50, remember, then went to 51, then we went to 50, then 51, 52, 51, 52, 53, so it looks like it increases, well, slowly. And then of course the last one here was at 54, and then we went to 55, and then the program broke. So you can see 50, in other words, we started at 50 really. We need to kind of tweak the program here a little bit. But we started at 50 and then went to 51. It's considering 50. Of course, I guess 50 is, right? And it's not showing it on the screen. Sorry about that. So 12 steps, really 13, I guess. The minimum is 50. That would be the, at position 50 was actually the smallest out of that sequence. Let's look at this one here. So 46. I'd like to see like 0. Whoa, look at that. So it looks like the smallest, so that took 424 steps to jump back and forth on the number line. It looks like it went as far to the left as 26. 6 steps. Let's do it again. And so, whoa, look at that. We are way over there. We are way out there. You know, when you start getting way out there to the left, it's hard to come back to 55. Look at here, negative 22. It took. We spent a long time jumping back and forth like that on our random walk here. 2,608 steps, and we went as far to the left as negative 22. That's amazing. Okay. What you'll really want to do is so this is one-dimensional space. What you'll want to do is actually do a random walk, like say for example, right, we're at we'll consider this the XY axis or something. Right, this thing is not drawing. We're at the XY axis, and we'll say this is at position 0, 0. So this is the Cartesian plane here, and let's say that we wanted to start our walk, let's say I don't know, making some stuff up here, 10, and we're over 10 and up let's say 5 or something, I don't know. Anyway, we wanted to do our random walk, and this is where we want to start. And of course, how many steps does it take to get here? So you can imagine we'd be going up, back this direction, right? These are all the possibilities here, right here, down here, here, and how many steps would it actually take to get to here? So pretend that there's a golden egg out in a field, okay? And you're trying to calculate what's the probability that it takes this person, let's say anywhere between 30 and 60 minutes to find the golden egg, if we consider that person is doing nothing but going on a random walk and eventually find the golden egg. See that? So actually I use this, I do treasure hunting, and I actually write up mathematical models to figure out these kind of problems. And of course, knowing a programming language really makes this possible by running this type of simulation. Okay, and I'm trying to figure out where we're at on this. Okay, so that's where we are, and I think I'm going to do a part B here. And what we're going to do is we're going to do this over and over and over again. So we're going to collect this data right here, the number of steps, and then we're going to run the program again, and then we're going to record the number of steps, and then we're going to do this again and again and again and again. And then what we're going to do is we're going to say, okay, what's the probability that I landed on 55? What's the probability that we did it between, let's say, 50 and 100 steps? See that? So we can ask these kind of questions. Okay. Alright, so I think we'll just end it there. Doing a little Python programming, looking at the random walk, running a random walk simulation, and I'll see you in the next tutorial.